The conditions for existence of Fourier series is called Dirichlet conditions. These conditions are given by Dirichlet, so they are named after him. There are three conditions. The first condition is the function should have finite number of finite discontinuities in the interval 0 to 2 pi. As you can see in the first figure, there are two wave signals, and first one is a square wave signal, and you can see that there are three discontinuities in the square wave signals. That is, at the first point there is value of 0 and 1. Signal is rising from 0 to 1. There is a discontinuity there. And in the second point, the signal is lowering from 1 to 0. There is a discontinuity there. And in the third point, it is again rising from 0 to 1. So in the period 0 to t0, there are three discontinuities. That is, there are finite number of discontinuities. In the second portion of the first figure, you can see that there are infinite number of discontinuities, because in the signal you can see a step like feature, and the first step has a width w and height h, and the second step has a width w by 2 and height h by 2, and the third step will have a height h by 4 and width w by 4. So there are infinite number of waves there, and there are infinite discontinuities. So there is no Fourier series expansion possible for such a series. So Fourier series expansion is possible only if there is finite number of finite discontinuities. And the second Dirichlet condition is that the function should have finite number of extreme values. That is, there should be finite number of maxima and minima in the interval. There should not be infinite number of maxima or minima. Here also, in the first part of the second figure, you can see that in the first time period, the maxima is represented at t0 by 2 and the minima is represented at t0. That is, there is only finite number of maxima or minima. But in the second part of the figure 2, you can see that there is infinite number of maxima and minima. This occurs because there is infinite number of cycles or periodic cycles in the second part of the second figure. So corresponding to each cycle there will be a maxima and minima. Since there are infinite cycles, there will be infinite maxima and infinite minima. So these two conditions can together be called as piecewise regular, or these two functions satisfying these conditions may be called as piecewise regular. There is another condition given in the next step.